Hi, good morning, everybody. How's it going? Hope we're all doing good. Today we are going to continue our practice with multi-step equations, okay? We've been practicing multi-step equations for about a week now, and then before that, we had been doing simplifying like terms. Then we moved on to one-step equations, two-step equations, and now we're on to multi-step equations, right? So remember, we're always building in algebra. We're always building on prior knowledge, okay? So the reason that we learned all the things we learned at the beginning of the semester is so we can put them all together and use them to solve beefier problems, right? Multi-step equations are beefier problems, and then the ones that we're into now are beefy also because they have variables on both sides of the equal sign, right? We just started with that, okay? So we're going to continue practicing that so we can keep building on what we've already learned and get really good at this stuff, right? So today, I've got 4 kind of big juicy problems that we're going to work through together, okay? So let's get started. So we'll do the first 2, and then maybe for the third one, I'll see if somebody feels brave enough to come up and do it on the board. Okay, maybe for a couple extra credit points. So let's take a look at your worksheet. Let's take a look at problem number 1, okay? Problem number 1 is 6x plus 3 equals 3 times, inside parentheses, x minus 4. Okay. So this is a multi-step equation, and how we do them, we've got a list of steps, right? I've got the list of steps pulled up here, or one version of them, but you also have it in your notes, okay? So in your notes, we always have our notes with us so we can reference our notes. I never want to make you guys memorize things. You don't need to memorize things. That's why we take notes, so we can reference them, okay? So what do we do? First step, if needed, we have to distribute, right? And if you forget, reference your notes, okay? Reference the first step of multi-step equations. When would we have to distribute? What would be the circumstance that we would have to distribute? Rena? Exactly, yes, if there's parentheses, okay? Because distributing means that we have parentheses with some math on the inside of those parentheses, and that we have a number on the outside that has to be multiplied by everything on the inside, okay? We have to do that before we can do anything else in algebraic equations, okay? So in this circumstance, do we have parentheses? We sure do, so we're going to distribute. So I'm going to take this 3 and multiply it by x, which gives me 3x. Then I'm going to take this 3 and multiply it by -4, which gives me -12. Boom, and that's it. We distributed. We got rid of those parentheses, okay? Now what do? Just like after we do everything, when we're working on an equation or any one step, we take our rest of the problem and we pull it down, okay? So I'm going to pull down my equal sign, and I'm going to pull down what I've got on this side so I can have a nice, fresh, new equation to work with. And every time we do anything, we're going to do that. Rewrite it, so it doesn't get all like wonky and sideways. It's really, really easy, especially when you're working with these beefier problems, to get messy and mixed up, okay? And so we want to avoid that by keeping nice, clean lines and rewriting our equation after every step so we don't mess up. Because again, it's easy. I mess up on accident all the time. That's why I have you guys out there to watch what I'm doing to correct me, right? And vice versa. We're all helping each other out here. Okay, so we did that. We distributed to get rid of the parentheses. Now what do? Well, let's take a look at our second step, which is combine like terms. Well, one thing to keep in mind when we're talking about equations and we're wanting to combine like terms, we have to remember that we can only combine like terms on either side of the equal sign, okay? I can't combine like terms across the equal sign, right? So that's something you have to keep in mind, if we're working on expressions, there isn't an equal sign, right? So you don't have to think about that. You just combine your like terms. But an equation has an equal sign, and we can only combine like terms on each side. So like terms on this side I can combine, and then like terms on this side I can combine, but I can't combine across the equal sign, okay? So let's take a look at this example on number 1. Do I have like terms that I need to combine over here? Well, I have a 6x and I have a 3. Are those like terms? Connor, what do you think? No, they're not. You're right. 6x is a variable term, and 3, what do we call it in algebra when a number is just by itself? Yeah, a constant, right? So these are not like terms. We can't combine them together. So there's no combining like terms for us to do over here. What about over here on this side? We've got a 3x and a negative 12. Yeah, no, there's no like terms. It's the same situation, right? So we don't have any like terms to combine here. We don't have any like terms to combine here. We're ready to move on to the next step, right? Which is what? Solving for x? Ooh, almost. Take a look at what we have happening here, though. Are we ready to solve for x? We're not, because we have 6x here and a 3x here. We have variables on both sides of our equal sign. And to solve for a variable, we need it set up so we have x equals something. If we have x on both sides, we're not going to be able to get there. So what do? Yeah, Zach, we have to get our variables on one side. We have to do something to make it so we only have a variable on one side of the equal sign. Yeah. And how do we do that? Anybody remember? Yes, Skylar, we have to get rid of one. Yep. So when we're getting rid of a variable term on one side of it, to get them on one side, it's up to us which one we want to get rid of, okay? We could try to get rid of this 3x, or we could try to get rid of this 6x, whichever one we want, okay? Let's try getting rid of this 3x. We do that by, if we have a positive 3x, we want to get rid of it, we subtract 3x, okay? Because 3x minus 3x equals 0. And then it's gone, okay? And we're allowed to do that as long as we do what? Anybody remember? Yes, Braden, exactly. The same thing to the other side. Braden said we're allowed to subtract 3x from this side as long as we also subtract 3x from this side. Because we have to remember, equal sign, having an equal sign is like having a balanced scale, right? Equals means balanced. If you do something to one side of that equation, it no longer equals the other side until you do the same thing, right? So if you do something to one side, you're allowed to, as long as you do the same thing to the other side and keep it balanced, okay? For that equals to be true, right? So think of it as a balanced scale. You can do anything you want to an equation, right? As long as you do the same thing to the other side, okay? So we can subtract 3x from this side, as long as we subtract 3x from this side. So 6x minus 3x is 3x. Now, we just bring everything down, right, that we have left over. We've got this plus 3, and then over here on this side of the equal sign, we have a negative 12, okay? So what have we done so far? We've distributed to get rid of the parentheses, right? We didn't have any like terms to combine. But then we made it so all of our variables are only on one side of the equation, right? So now we have 3x plus 3 equals negative 12. So we're getting close, right? We're getting close to solving for x. What do we do now? Are we ready to solve for x? Yes, we are. And how do we do that? Well, if you forget, take a look at your handy dandy note sheet. Step 3 here says add, subtract. That means we get rid of the addition and subtraction first. Remember, order of operations says we do add addition and subtraction last. But when you're undoing something, you have to do the opposite. So we have to go opposite order of operations, right? If we want to undo stuff. So that means we have to undo addition and subtraction first. And again, it's okay if you don't remember that. You have the steps in your notes. Okay. So yes, the operations attached to our x, we want to get rid of. We're going to get rid of the plus 3. This is the first thing we're going to get rid of, okay? How do I get rid of a plus 3? Yeah, I do the inverse of it, or the opposite of it, which is subtract 3, okay? Why does that work? Because positive 3 minus 3 equals 0, and that's what I want. I want to get rid of it, right? Okay. So now on this side, I'm left with only 3x, which is, I'm that much closer to having x by itself. I'm going to bring down my equal sign. And what am I going to do over here? Uh-oh. Am I allowed to subtract 3x from this side? Yes, as long as I do the same thing to the other side. So if I subtracted 3x from here, I also have to subtract 3x from here. Or sorry, 3. I subtracted 3 from this side. I have to subtract 3 from that side, right? Not 3x. Right now we're getting rid of that constant. Okay. So what is negative 12 minus 3? Yep, negative 15. Okay. So we did it. We did our adding, subtracting step, right? We undid the addition and subtraction. Okay. We have one operation left connected to our variable, okay? And what is it? Yep, exactly. 3x means multiplication, right? When you have two numbers, right? 3 is a number, x is a number, although it's a variable, it's still a number. When you have two numbers right next to each other in algebra, it means multiply, okay? It means multiply. So this means 3 times x. So we have 3 times x equals negative 15. I want to get rid of that times 3 to get x by itself, right? How do I do that? Well, take a look. Step 4, we undo our multiplication and division by, yes, doing the opposite or the inverse, okay? You got to think, and you also have this in your notes, what is the opposite of multiplication? Connor? Exactly, it's division. So if we divide 3x by 3, 3 divided by 3 is 1. That leaves us with 1x, and that's what we want. We just want one lonely x, okay? And we're allowed to do that. We're allowed to divide this side of our equation by 3 as long as we divide the other side of our equation by 3, exactly. So now we're left with x equals whatever negative 15 divided by 3 is, which is, Emilio. Yep, awesome. Negative 5. X equals negative 5. Okay. See, that was kind of a beefy one. We had to go through all the steps, but you guys are getting a lot better at this. So we're just going to keep practicing, okay? We're going to keep practicing, and then we're going to have a quiz on this probably Thursday, okay? All right, so we're going to do 2, 3, and 4 together, and then I might have you guys do a little practicing of one on your own, okay?